Hello guys, so we're live once again with our live streams, and if you haven't already and you're following with us, you can subscribe to the channel and also turn on the notification bell so that you get notified each time I will live stream. So usually I will live stream at this time, so at 20:45, so 8:45 p.m. on Monday. So if you want to check out this course, you can sync at this time. And today we're going to talk about SEAL classes and interfaces. SEAL classes and interfaces provide controlled inheritance of your class hierarchies. So all direct subclasses of a SEAL class are known at compile time. So this means, that all the subclasses of a SEAL class are known to the compiler, and no other subclasses may appear outside the module and package with which the SEAL class is defined. So if you make it sealed, you cannot have other subclasses outside of the module and package. The same logic applies to sealed interfaces and their implementations. And once a module with a sealed interface is compiled, new implementations can be created. So once a module with a sealed interface is compiled, no other implementations can then be created of that module. So direct subclasses are classes that immediately inherit from their superclass, okay? And indirect subclasses are classes that inherit from more than one level. Okay. When you combine SEAL classes and interfaces with when, you can cover the behavior of all possible subclasses and ensure that no new subclasses are created to affect your code adversely. So this is very useful, and this is why I have used subclasses in the past. SEAL classes are best used for scenarios when you have limited class inheritance desired. So you have a predefined finite set of subclasses that extend the class, all of which are known at compile time. And then they're best used when you have type safe design is required. So safety and pattern matching are crucial in your project, particularly for state management. In fact, it's used also in some plugins that I may show very quickly, or handling complex conditional logic. So for example, check out use SEAL classes with when expression, which I think will be inside this document. Yeah, over here. And working with closed APIs. So we want a robust and maintainable public API for libraries that ensure that third-party clients use the APIs as intended. So you are making a SEAL class if you want to expose probably a public API. That's what they want to say. For more details, use case scenarios here in state management and payment method handling, API request response handling. That's interesting. So Java 15 introduced a similar concept where SEAL classes use the sealed keyword along with the permits flows to define restricted hierarchies. Okay, but we don't use actually Java. So declare a SEAL class or interface. To declare a SEAL class or interface, use the SEAL modifier. So you as they said, you can either use it on a class or an interface. So let's read on this example, then we'll go to our coding. So we can create a sealed interface like that. We can create a sealed class that implements the sealed interface error with this syntax. So it inherits from the interface, of course, and the interface is sealed. And then, so no other interfaces can be created from error. That's what I suppose will happen. Maybe we can test this very quickly, but let me create maybe inside product. Yeah, we can make this sealed. So let's test if it runs first to avoid any issues. So I'm making our product implementation, product interface, sorry, from last time sealed, and then we will have our product implementation which inherits from the seal class, and it looks like it's running. So we don't have other issues. What I want to show you guys is that if I try to make an interface like product extras from product, let's see, works. Yeah, it does, but probably, yeah, I can also make it sealed. So you can mark this as sealed, and let's see what I do here. Yeah, I can also do this. So I can extend the interface as I wish. And that's interesting. And I can also create a class from both interfaces. Let's try it out. So product extras equals to product. Yeah, of course, you would need to implement this inside here. And we would need to implement test product extras. Oh. This is a test, and this way, if we create the product implementation, of course, we need to pass in something like here, and then we can say product extras.test. Because we are inheriting from product extras, let's run it. Okay, so this thing is working, so you can have inheritance. And you may also have a seal class. So I want to check something very quickly in my previous codes. Just give me a second, please. So yeah, just to show when this is useful. We'll get to this in this example, this use case here. But basically, when is this nice to have? When you have something like this seal class. So of course, we will need to create a state, maybe. Let's create a state, a folder, and let's create a state file. And then we have this seal class. So the seal class may be something like UI loaded and go back to say that you want to go back in the previous screen. And this data class will inherit from, it will create an object of the seal class. So it creates an instance of this class. And why is it useful? Because you could use something like state equals state. And now let's import this. We have multiple, so let's say custom state. All right, so that we get, nope, we don't get it. Create class. Why can't I import? Let's do import. Probably. What I want to see. This package dot custom state. I don't know why it's not. Okay, yeah, because you cannot access the init. So since this is a seal class, I was wrong here. I don't want to create an instance of custom state. The instance of custom state is created by UI loaded and go back. So here inside our state, what I want to have is custom state as the this should be a custom state, and then I want it to be something like go back, or maybe at the start it could be loading, and then we can change it to go back. So like this is our state, and then we may change our state to something like custom state dot go back. And of course, this has to be a variable now. And what we can do is we can say each time we initialize the object, we just print it, and the state change to it print line. Too many arguments for what is going on here? Oh, that's fine. And here, let's see what we can do. Yeah, we can do this. Perfect. Let's see. So yeah, as you see, state change to loading and state change to go back. So we will see this also later probably, but this is how you can use effectively the sealed classes. For example, to have a state, and this is useful because you can change only to predefined values from custom state, and you cannot assign something from another class like product, for example, here, because that would raise an issue. If you try it, you can see that the state, the custom state was expected because, of course, we're asking to have a custom state. Okay, let's go on. So that's what we have here. Yeah, we have our seal class, which is IO error and file read error and database error that inherit from IO error, which is our main seal class. So what we could have done here to make this example better could be something like, let's go back here and let's create error, and let's have error.kt, and here let's have this, and then our seal class could be this. Import, I don't want this. Let's put string and not import the sources. And then, yeah, we may have our object. This object, maybe, yeah, it could be inside the interface. So now it should make a little bit more sense to have it like this. So this is an instance of, yeah, this lies inside IO error, and all the IO errors will be defined here. This could be a way to do it. This example represents a libraries API that contains error classes to let library users handle errors that it can throw. If the hierarchy of such error classes include interfaces or abstract classes viable in the public API, then nothing prevents other developers from implementing or extending them in the client code. So since the library doesn't know about errors declared outside of it, it can't read them consistently with its own classes. However, with a sealed hierarchy of error classes, library author can ensure that they know all the possible error types and that other error types can't appear later. So all the error types will be defined in here, and you cannot have more of them. So you have our sealed interface. Maybe there can be an object like runtime error that inherits from this interface. And then you can have a sealed IO error, which implements the error interface. And then you can have both a file read error and a database error, which inherit from our seal class. So that's good. Let's go on. So constructors, a sealed class itself is an abstract class. So the seal class, like we have here, is an abstract class, is always an abstract class. And as a result, it can't be instantiated directly. So this class, let's say it here, this class is abstract and cannot be instantiated. This is what we have seen before. If you remember, I was trying to set custom state object like this, but you cannot access the init because this is a sealed class and it's abstract. So I will type it here. Custom state is abstract and cannot be instantiated. However, it may contain or inherit constructors. All right, these constructors aren't for creating instances of the seal class itself, but for its subset classes. Yeah, so we have seen this in our loading test. So we had our initializer constructor that was just printing the state as soon as the data object was instantiated. So if you remember, we have set loading and we have set callback. Same. Okay, so consider the following example with a seal class error and its several subclasses with which we instantiate. So we can also pass, as you see here, some arguments to our seal class. for example, let's transform this. We may have our new seal class here directly error, and then we can say val message bring, and they are doing in example. And then we have our classes like, let's see what they have done, network, database, and unknown. So network error, and this is an error, and network issue. And so we're basically, redeclaration of error, of course, error, custom error. Oh, so we have network issue, database error, issue, and unknown error, and then unknown issue. So this is our custom error. And we can, as you see here, they are making a list and then they're cycling to them. And what happens is that in this case, they're printing the message. So that's what you get as output. We can do the same over here. Custom error equals. So we say this is custom error, and then we have custom error dot. Actually, you would just want to print them, so you can do something like custom error dot. Let me see. Then, all right, we have to create a list of these errors. Let's do custom error dot database, custom error dot network, and so on. Unknown. We create an instance of all of them. Then we say for each, and then we print the message. .message it.message, and then we just run it. Maybe we place a print line over here, and we're good. So you can use the enum classes with your silk classes to use enum constants to represent state and provide additional details. So that's also interesting. Let's see it here. Each enum constant exists only as a single instance, while subclasses of a sealed class may have multiple instances. So basically we could create two instances of this, whereas the enum is always the same object. That's the difference. So like this is another instance of that, and you can do it, you can create it, whereas the enum constant is a constant that has always that it's always the same instance. In the example, the sealed class error along with its several subclasses employs. In the example, the sealed class error along with its several subclasses employs an enum to denote error severity. So each subclasses may a subclass constructor initialize the severity and can alter its state. So you may use it in a conjunction. So we just copy the severity of the issue. And then we have to, of course, create a variable severity inside our custom error. And then we can add something like minor. Yeah, we'll do it in our custom example over here, just to show it. Let's do this major. And then we can, of course, have it printed also here. And let's run. Okay. Constructors of a seal class can have one of two visibility: is protected or private. So constructor can be either private or protected. So if yeah, I just want to check something at the start. Yeah, no other subclasses may appear outside the module and package within which the seal class is defined. So let me check. Our package is org example state, and we're using that in our example. Just I'm not very sure if that's right. So let's define an error here. Custom error, yes. Yeah, of course you can do that. I have to do something like this. Oof, I'm doing out an interface. I wanted to do it here. Yes, you can. So here we are inside the same package, same module, Kotlin org. Maybe I don't think if we change the package, maybe we can try test. So yeah, Kotlin. Let's see. Maybe let's call luca/org, and then let's do test.at. And what I want to do here is create a functional test that will just create a custom. I just want to check if you can create a custom error from here. So yeah, of course, this is the interface, and then we have custom error dot database error. No definition. Interesting. Let's try and run this. Okay, you can still run it. I'm not sure why you cannot access that. Print line. Let's try and print it, and also let's call from app our code. Print, not print, but test sealed on other package. Okay, you cannot access the Luca org. Maybe it's because of its visibility. I don't think so. So let's try and create a class test with seal, and let's place this in there. So these two packages cannot see each other, maybe. Test yield. They cannot see each other, so I cannot test what I want to test right now. Ah. By the way, it's strange that the linking is not working. I would need to dig into this. I think it's not important now. So we have our constructors. Okay, and then they can be private or public. Then we can have inheritance. Okay, direct class, subclasses of a seal class and interfaces must be declared in the same package. So subclasses and seal classes and interfaces might be declared in the same package. There may be top level or nested inside any number of other named classes, named interfaces, or named objects. Subclasses can have any visibility as long as they are compatible with normal instance rules in Kotlin. Subclasses of the sealed classes must have a property qualified name. They can't be local or anonymous objects. You may have, as you see here, an enum class that inherits from an interface. That's fine. A sealed interface, sorry. So like we had over here, sealed interface. We may have this inheriting from error, and that would be fine. Okay, the scrolling on this website, I don't know why. It's a bit bad. But these restrictions don't apply to indirect subclasses. If a direct subclass of a sealed class is not marked as sealed, it can be extended in any way that its modifiers allow. So this is also allowed. You can have a custom error. Yeah, that would be something like type sealed error. Let's go with like this. And we can have our custom open class custom error that inherits from our sealed interface error. That's fine. So you may have another class that inherits from here. For example, it can be directly this one. And this way we may have custom error here and here. You see? So this basically, this IO error and sealed error, like we could call it, maybe it's better, even better, app error. So we have our app error and IO error that can inherit from our custom error, and then this will inherit from the interface, and that's a possible structure for you. There is one more Inheritance restriction in multi-platform projects. Direct subclasses of seal classes must reside in the same source set. It applies to seal classes without the expected and actual modifiers. So if a seal class is declared as expected in a common source set and have actual implementation, both expects and actual versions can have subclasses in their source sets. Moreover, if you use a hierarchy structure, you can create subclasses in any source set between the expect and actual declaration. So this is related to multi-platform, where you have the except and actual keyword. The except is usually is used as a way to say expect an implementation of this class in the actual implementation, which comes from the specific app code. So like iOS, Android, desktop, web, and so on. But this is related to multi-platform. We'll skip it and we'll look at it in a later course. So use seal classes with when expression. The key benefit comes to play when you use the when, of course, of seal classes, as we mentioned at the start of this course as well. So the when expression is used with the seal class allows the compiler to check exhaustively that all possible cases are covered. This we have seen it also in some examples at the start of our course, but we'll also see it now. In such cases, you don't need to add an else clause, because otherwise, if you don't cover all cases, then the compiler will throw an error. So let's try and cover all the cases of our app error. We have, what we can have is something like, okay, I am creating our error, which is this, and now I'm saying okay. So if you have this error, then do something, otherwise do something else. Okay. Error should be app error. Yeah, this makes more sense inside a function. So let's do something like uncheck error and print something. And here we pass app error. Then we can have when e, which is our error. And then it will say this expression is unused, and we have to add all remaining branches. We can do this in a click like this, and then we can implement the to-dos as we wish. And here we can say something like network error, line, database error, and so on. This is one possibility. Now I thought of something else, like check error retry. We can call this check error retry, and in case of database error, we can say false, don't retry. In case of network error, we can say retry. In case of unknown, we can say don't retry. And then we also return this. So I can do print line, maybe inside here, print line, should I retry on this error? And then I can say check error retry, and then say pass the error instance. which is IT, and we're good to go. We can run it. So it will say, should I retry? In this case, no. In this case, yes. In this case, no. That's the simple usage of the when expression. You can also add guard conditions to include additional checks in a single branch. More information on guard conditions is in when expressions, but we have seen that this is experimental and you need to add some compiler options. We don't want to do that now. So the idea is that you can also add an if inside here, but guard conditions can also be emulated with something like this. So I don't know. Let me check. We could say if something happens, then do this, else do something else. Like, what could it be? Something like is corrupted, and if database e dot, yeah, we have to pass it. So e has database error. If discuss another succeed. Oh, that error, sorry. Yeah. Database corrupted. Yeah, so you don't need this. Perfect. If it is corrupted, then you don't want to retry, else you want to retry. That could be an idea. So we can have true here, and we can have another error here, which is false. And then the check error retry will change their behavior based on our condition here. So in this case, it will be false. In this case, it will be true based on the Boolean that we pass when we create the instance of database error class. So yeah, in multi-platform project, if you have a seal class with a when, in common code, you still need the last branch. This is because subclasses of actual platform implementation may extend seal classes that aren't known in the common code. Okay, so you will need an else branch, and here it's not actually needed. Yeah, we may say that it will be unused. Use case scenarios. Let's explore some use cases when they are useful. So as I've shown at the start, we can have a seal class to represent UI states. This approach allows for structured and safe handling of UI changes. So for example, you can have a seal UI state. We had to call these our custom state. We can call it UI state as well. We can have a data object loading and then data class success or data class error. So we can extend our implementation here, and we can have a success. And here we can have a message, and we can say string, and then we can say UI state. And we can have also an error called error custom error. Yeah, it's not custom error anymore. I think it was error. Maybe we can leave either custom error or error interface directly. Yeah. Constructor has no nullable self parameter. Oh shoot. So we have to say UI error. Okay. Doesn't want these. Let's recall these I error. Now let's go back here. I error and let's import it. Okay, perfect. Now we're good to go. And of course, we can say when we have a state like this, do this, otherwise do something else, and so on. And that's very useful if you have code in which you want some UI. So let's try this. All remaining branches. Here you may say going action screen. Here you may say print line loading screen. And you may say print line success. Loaded. And you could say UI error line. Okay, this won't work because these couple labels types. Let me check something. Yes, missing this. Perfect. Oops. Print line error ongoing. And then we can create function state, UI state, and then we can call it here split state, and then we just pass in here this, or maybe yeah, it would be better to have state and state. So we update those states, we should get proper printing over here. So state change to loading, state change to go back, and also that makes sense. All right. Let's go on with our guide. So payment method handling. So if you have a payment with different types, and like credit card can have a number and expiry date, PayPal may have an email, and cash can have nothing, then you may do the when. Also here with different concepts, and then you may have payment, yeah, process payment credit with pin number and so on. And these are all subclasses of payment. This is something similar to what we have done with check error retry. Oop. So our last example is API request response handling. You can use styled classes and interfaces to implement a user authentication system that handles API requests and responses. The user authentication system has login, logout. The API request styled interface defines specific request types such as login request, logout request, and the sealed class API response encapsulate different scenarios such as user success with user data, user not found for absent users, and error for failures. The handle request function processes the request in a type-safe manner using the when. So we have our sealed interface API request, and we have our data class login request, which inherits from our sealed interface. Then we have our object over here. And then we have our sealed API response class, which has 3 objects: user success not found and error. This is the response that we're giving in each API call. And then we have our user data class. This is just the definition of the user data class. And let's see where they're using it inside this code. Yeah, so we're passing user success with user data. So basically, they're handling the request. The request is API request. So it can be something like logout, something like login. And when you handle the request, if it's login, then you check if it's valid with the username and password. Otherwise, you throw an error. And if it's a logout request, you just return the logout data as success. So the logout will also succeed in this example. And we have, simulate get user by ID. And this returns still an API response. So it returns the user with some certain parameters. That's a nice example. Maybe we can go through it, but I will try to be as quick as possible. I don't think we will have time for the generics, which is a long topic by itself. So maybe we'll just create this. Okay, this isn't Ktor, but we can skip the resource and serializable. And we can create a similar example anyway. So let me start with this. API request. Not API request, API. And then let's say we can create our requests. And let's delete these as we said, because we're not using Ktor. So we have our login request, which requires username and password parameters. Then we have a logout request, and we have our sealed interface. Next, we create our response. So responses. Our response structure is like this. And what we have missing is user data about PT. Yeah, so this is sort of a response, so we could directly place it here. So we have, in case of success, we return user data. And then we have our functions. So extensions. Maybe we can, we can call them object. logical part, what it will do. Yeah, we can do something more fancy here. So let's remove this. And here we can say on is valid. And what we can do is user ID equals to valid user valid pass. And use and password. Where is the password? Oh, because they're passing it. Yeah, the user data. Oh, shoot. It should be a user. I thought it was. It's bad. Because the user is not the user data class. So here they're missing data class user. It should have username and password, in my opinion. And it should have, yeah, it should have the same properties as there, but it should also have the password. That's the issue. And now it makes sense. So where do that? I think it should be something like this. User string and then yeah, name and email, we don't care. So we have our user and password, and if it's valid, we pass in valid user valid pass, and that's good for us. And we need to have user ID greater than 0. Okay, to be valid. That's what we want. Then let's go to handle request. Of course, we don't want to pass in the password with our user data. So we may arrange something like this: data class, user data, user, users, and then we inherit from user data. Okay, this cannot be data class. Password should be open. It should be overridden. Overridden. Yeah, I was wrong here. This is user ID. This is user. Open. Open. Okay. Now we're good. So let's now. This cannot be data class. Yeah. It has to be an open class, not a data class. Next, so we handle our request. We just do one of the two, like this one, because it has the when, which is more interesting, and we do handler request. So So we do it directly inside the user. I think it might be best. So request, or request can be a login request, and our username. Yeah, let's just call this username for clarity. And here. And now we pass in valid user and valid pass. And that's good. Active member declaration. All right, so oh, what am I doing, guys? Starting to become to become tired. So when the request is this is not login request, this is API request. So this is API request. So when we have login request, we do the login, and let's see how they are doing it. Yeah, they check if the user is valid, of course. So we create our user. It makes sense to have a user ID here, but whatever. We can just place it there. Valid user, valid pass. So in this case, it's valid. Yeah, we have to pass the request. Gosh. So yeah, we create the user with the request data. So we're creating this user and we check if it's valid. If it's valid, then we say is logged in. So we return the response. And inside the response, we can say user success. So not found success. And we can return directly the user. So let me do something like this. Create another parentheses here, parentheses. Okay, wait. So if user is valid, else appear response not found. Now here we need to pass user data, but since the user data, the user inherits from user data, we can pass it like that, which is very convenient for us, right? But yeah, actually, this could be a companion object function. Because we don't need an instance of user in order to, yeah, we're creating the instance of users here inside the function. So we don't need, this doesn't need to be a function of user. So I hope this is clear. Then we have our logout, which is API response dot user success I mean, we can say user logged out. So user logged out. We don't need to return the success. Like this. Okay. I liked it. I like this. So now what we need to do is handle a request. So pull this function from our app and let's create a pull request. Handle request. So this comes from, we said user dot handle request. It's never used. Import the example or the example API here. Right, and here we pass our request API request. Specifically, we pass login request. I like it more when we place it inside the field interface. Login request. And we pass in this port. Then we pass in valid junior and valid pass. And then we pass logout. Okay, we have an issue. Oh, import issue. All right. Not sure why we didn't have it before. So everything is working, but we don't have anything printing. So print, and we should print all the responses. So we should be able to print all the responses now. Yeah. So in first case, we're passing no user, no password, and we get user not found. Second case, we pass in the proper username and password, and we're good to go. So if we pass something like test, should get user not found. And if we pass in the logout request, then we will see user logged out. So that's interesting. Yeah, I like this. And we could also call is valid from outside. And we can do also other fancy things in this code. Like what one thing we can do, and then I will stop, is we can make this, instead of creating the object like we're doing here, we can do is valid directly and then pass this. That's another option of implementing this function. And the advantage is that you can create a user outside. So you have to create it here. And at this point, you don't need to pass the variable, yeah, the username inside here. actually. And this would be just a login request. Like this. You see? Oops. Yeah, this should be a data object now. And here we should have something like that. And then same here, one best, and the request, request. Great. Good. And then you get the point. So if we store this user, we can reuse it later. That's the other advantage. So we can have printline user dot handler request, and we can have API request, logout request. And what's interesting here is that let's delete this. Okay, the parentheses here. What's interesting is that you may store also the result inside our object user, so you can have fun log true false, sorry, and if you log in, sorry, not variable, and then if you log in, you can say it's true, and if you log out, you can say this is false. And of course, just if you want to make sure, you can say it's false when it's not found. So if I call all of these, and if I want to, you can have a vacuum property here, and then we can have our value is logged, and I can check its state each time I want with this. So if I go here and I print line the user, I get it all the time. All the time I can get the variable I want. And as you see now, we have to pass the proper user in order to log in. Was valid user, valid pass. So valid pass. So in first case, we're passing the proper user. In the second case, we're passing the wrong user. And as you see now, we have user success. In this case, we have a successful login operation. And in fact, if we see the isLogged variable, we can see that the user is logged. And then if we ask the logout, then we reset the isLogged state. And we properly see that the isLogged function is false now. And of course, if we log in with a wrong username or password, if we say user not found, then isLogged will be false, which is our default false value. And also here we're enforcing the setting it to false. Okay, so that's something you can do in your code in order to create simple and clean code, I would say. What else? Yeah, one last thing I want to say is that, as you see here, we have only a getter, so you cannot set is logged from outside. So this is also secure, because if you try to set it logged, You cannot do it. We'll say it cannot be resigned. It has to be a variable in order to do so. But we want is logged to be a value only readable from outside, and we want our setter to yeah, our backing property here to set the value inside our handle request function only. So guys, it's all for now. I hope you enjoyed the video, and I hope you subscribe to the channel if you like this type of content, and if this will help you on your way to master Kotlin. So thank you guys for watching. We'll talk about, we'll talk about well, let me check generics next time, because I think it will be a long topic, and we have sticked to silk classes this time, and I'm happy to have made it in 1 hour and 15 minutes. So thank you guys for watching. See you next time.